Coming up on this week's episode of TechSNAP, it's a trifecta of Unix vulnerabilities, our concerns with LessPass, and a very valuable vulnerability. Plus your questions, our answers, a spicy roundup, and much, much more on this week's episode of TechSNAP. Hi, everyone, and welcome to TechSNAP. This is episode 292 of Jupiter Broadcasting's weekly systems network and administration podcast. We stream this episode on November 3rd, 2016. This episode's brought to you by our three fine sponsors, DigitalOcean, Ting, and iXsystems. I'll tell you more about those great sponsors as this here show goes on. Oh, our live stream and all of the downloads over at jupiterbroadcasting.com, well, that's powered by the incredible Scale Engine. Go check out Scale Engine. My name is Chris, and joining us every single week is our host, the admin, the tech, and the teacher, Mr. Alan Jude. Hello, sir. Hello.
Hello, Chris, everybody. Thanks for watching.
I am looking forward to today's first story already, Alan, because it's called a trifecta. Anytime you got to let that with cheese and pepperoni and a Triscuit, that's a trifecta of deliciousness. But you have a trifecta of Unix security, and that sounds rather fascinating. We've got some great feedback coming up and a fun round. We got a big show. You want to just jump right in?
Sure. This week we have the trifecta of three of the most important and widely used Unix services, all having vulnerabilities.
I love it. And in fact, I went to go read up on some of the CVEs that you linked in the show notes, and at least at the time we're recording, CVE 2016-8610 isn't even public yet. So what's going on here?
Yeah, that one's a little fun with that one. But OpenSSL contains a vulnerability where a remote attacker who can initiate a handshake with an OpenSSL-based server. So that's basically normally anybody on the internet, right? Because the first thing you do when you connect to SSL is negotiate the handshake with the other side. Can cause the server to consume a lot of computational power with very little bandwidth usage. This may be used as a technique to leverage a denial of service attack. So I can use a very small amount of bandwidth and cause OpenSSL on your server to use a whole bunch of CPU time. That means if I have an entire botnet of toasters, which are on the screen for some reason, then I can have them all initiate a handshake with your server using a very small amount of bandwidth, but using up all the CPU on.
This is a clever one. Server. Okay, makes sense.
So the flaws in the way that OpenSSL handles SSL alerts. The SSL alert protocol is a way to communicate problems with the SSL/TLS session between the two hosts. Due to improper handling of alert packets, OpenSSL would consume an excessive amount of CPUs trying to process undefined alert messages. So basically, if I connect to you and send invalid alerts rather than valid ones, your machine will spend a whole bunch of CPU time trying to figure out what the hell I was talking about.
Yeah, sure.
If I do this enough with thousands of connections, even though that will only take very small amount of bandwidth from me, it will keep your server busy for a long time and do it enough, and there won't be any CPU time left for that server to answer real requests from real users, and the website will be down. Or, if they auto-scale with Amazon or something, you could just run them up a huge bill by using up all the CPU time of lots and lots of Amazon.
That's evil.
Yeah. It's almost worse than, if you're just taking out their one web server, it's down until they stop attacking or they fix the bug. If you do this to Amazon, you can bankrupt the company.
Mm-hmm.
So that's the first one. The second one is CVE 2016-8864, which is a vulnerability in bind.
Okay.
A remote attacker can cause a server to make a query deliberately chosen to trigger in a failed assertion, which would cause the named daemon to stop, resulting in a denial of service for its clients. So if there's a server that's willing to do DNS lookups for you, usually they're restricted to only do it inside the LAN, but you could also do this. Many servers are set up to use a local caching name server.
Yeah, for sure.
If it happens to be bind, if I, via their website, can cause them to look up this address that will crash their bind, their server will be unable to look up any addresses.
Which could
also
be
a denial of service.
Yeah, well, it could screw up a whole LAN too. I mean,
yeah, exactly. You could take all the clients on the LAN and suddenly have no DNS.
Yeah.
So a defect in bind's handling of responses that contain a DNAME record could cause the resolver to exit after encountering an assertion failure in db.c or resolver.c. So you could basically ask name to look up a certain address. The response is invalid in some way and causes bind to crash. And then bind's not running anymore, and nobody can do any more DNS lookups until somebody fixes it.
And all kinds of things break.
And then you just crash it again.
Yeah. Well, just think about all the things that break on a LAN when DNS stops working properly. What a mess.
Or like your ability to go to Google.
Or in a lot of cases,
People will
print.
say the internet's down if DNS is down.
Internet's down, but also there's possibility, like especially in an Active Directory domain, DNS plays such a critical role to communication.
yeah, you won't be able to. SSH scripts that connect to other servers might not work. Email's not going to work.
Right now, those Windows admins are like, this is why I have all my DNS running on Active Directory Windows servers. This is why. This reason right here. They're all sitting there right now going, this is why. I told you guys. I told you. Okay, you get this one.
And then the third one is CVE 2016-8858, which is a bug in OpenSSH. A remote attacker may be able to cause an SSH server to allocate an excessive amount of memory. So instead of using up all the CPU like they can do with OpenSSL, with OpenSSH, you can use up all the memory.
Yeah, especially if it's like limited to 16 gigs, but only really crazy expensive laptops would do that. So
note that the default setting on FreeBSD is to limit there to being 10 half-open connections. After 10, it starts dropping 30% of incoming requests, scaling that up to 100% once there are 60 half-open connections. I don't know what the defaults are in other operating systems. But so during the SSH handshake procedure, the client and server exchange the supported encryption, message authentication, and compression algorithms that they support so they can pick the best one that are supported by both sides. They negotiate the algorithms as part of the initial key exchange with the SSH message key exchange in it, or message kex in it. When processing that key exchange initialization message, the server can allocate up to a few hundred megabytes, or a few hundreds of megabytes of memory for each connection before any authentication takes place. So if I can connect and use up even, say, 256 megabytes of RAM each, if I can connect 10 times, there's 2.5 gigs of your RAM gone. If I can connect 100 times, there's 25 gigs of RAM that you don't have.
Oy.
Easily could take out, imagine a droplet with 2 gigs of RAM. If I can connect the 10, even just the 10 times with like a tight configuration would have, and use up 2.5 gigs of RAM on a machine that only has 2 gigs of RAM, then it's out of memory.
And what do I have to have on my end to do it?
As the attacker or the...
As the attacker, machine? Yeah, as the attacker.
All you need is basically a modified version of SSH that will send one of these, basically a giant, an infinitesimal list of these algorithms you support.
So I'm getting like the sense that I should patch my stuff.
Yeah, patch your shit. So most of your OSs will have fixes for these, or will by the time this episode comes out a week from when it's being recorded. So you want to make sure that you get everything all patched up. Yeah. Because, OpenSSL is like basically every web server, but also your email server uses it, your browser uses it, lots of things use it. And bind, DNS is kind of everywhere. And SSH. I don't know anybody whose server doesn't have SSH running. So really, any SSH server that remains unpatched in a couple of weeks will be vulnerable, and will just stay vulnerable to this. I mean, this is just... I mean, and the thing is, so many servers have SSH. It might be a very easy way to take out a bunch of the Mira botnet type things. If they support SSH, you could just hog all their memory and kill them. Yeah, exactly. This could be a good counter defense to little cheapo Internet of Things devices that are running around with infinitesimal amounts of memory. Well, because the interesting thing is the way we normally kill those is by changing the default password to something random so that all the botnets can't connect. Except for with some of these, we found that it's not possible to change the password. So maybe just breaking them entirely by just constantly spamming all known vulnerable Mira botnet machines with this SSH attack or something. This also seems like a great way to take SSH down offline after you get into a machine, you compromise it, and then you could use some of these to screw with it so that way somebody couldn't come along and try to connect to it later on and try to figure out what's going on. You can definitely help, things like locking your administrators out or locking the administrator out so that they can't reclaim the box after you compromise it.
Yeah, boy. So look for patches coming to a neighborhood near you soon and install them right away. Do you have anything else on this, or any other notes or things to pass along for people that might be affected?
Nope, just
Patch
there's
soon.
CVE numbers, so you can look for those in the vulnerability list on your.
But we don't have. There's no code yet, right, to fix this?
No, all 3 of these are fixed in FreeBSD today.
Oh, they are. Oh, okay.
Or they came out on Tuesday, I think.
So the upstream projects have released code.
Yes.
Okay. I misunderstood and thought that there wasn't anything available yet. And I was like, oh, okay.
Yes. All these are fixed in FreeBSD. I haven't looked at other operating systems yet. But Red Hat, if you search the CVE, even though NVD doesn't have it for the OpenSSH one, Red Hat has a whole thing on it. So
Sure.
I'm sure it's fixed there as well.
They patch. They know how to do it. And you know how to get it. So the problem. I'm good. I'm glad. I thought we had a disclosure with no upstream code. No, that can be a real crap show. You know what's great though is DigitalOcean. DigitalOcean.com. Use our promo code SNAPOcean and go spin up a rig for free with our $10 credit. You can try a $5 rig and run it 2 months for free, or look at their hourly pricing they have over here and run it for 3 cents an hour, 6 cents an hour. It's a great way to go. And speaking of vulnerabilities, they're constantly, obviously, you can just get patches and install them. It's not a problem. But they also will have any kind of guides or tutorials to help you secure your system. Like here's one on how to protect your server against the dirty cow vulnerability. Another one on installing and configuring OwnCloud on CentOS 7. One on configuring Nextcloud on Ubuntu 16.04. I think that when you combine DigitalOcean's super easy to use, intuitive interface, their really great documentation, and their crazy great pricing, that alone is enough reason to check them out. Sure, you get to support the show too. But there's other nice things about it once you start using DigitalOcean for a while that are really handy. Building multiple droplets, being able to use templates, be able to share accounts with teams or transfer droplets to other accounts completely. And a lot of the things that you end up doing on a routine basis are totally doable. All of them are doable via their API. And you start to take advantage of that as it goes on. Either you build something or you take advantage of something somebody else built. But don't worry about that now. Just go check it out for a little bit and use our promo code SNAPOcean, one word, lowercase. Have you been thinking about trying out Nextcloud, moving something off of Google, or hosting your own GitLab and getting off of GitHub? Maybe you want to run a blog like WordPress or Ghost on there?
Or maybe it would come in handy with the next story?
Perhaps. DigitalOcean.com, just use our promo code SNAPOcean and go try them out. And, of course, they have Ubuntu, CentOS, CoreOS, Fedora, Debian, and last but not least, they also have FreeBSD, including version 11 of FreeBSD. And then you could have a lot of fun when you play FreeBSD with ZFS, and then you start using their block storage. It could get really cool. And then why not combine things like their private networking, where you can do transfers that are inside the private data center, not over the main internet, that don't go against your transfer. You can really do some cool stuff. And really make it powerful, they've got an HTML5 console where you can get console access from BIOS all the way to post. And that's really enabling. Check it out, DigitalOcean.com. Use the promo code SNAPOcean. And a big thank you to DigitalOcean for sponsoring the TechSNAP program. Thanks, you guys, and thanks everybody for using our promo code to support the show, SNAPOcean. Now, let's discuss LessPass. It's getting a lot of traction in the Linux Action Show community right now. A couple of people in here, JB, have been talking about it just today. So I was really
Rakai specifically mentioned it to me.
Yeah,
so.
Yeah, and there's been some dialogue about maybe jumping ship from something like LastPass or KeyPass to LessPass. So, how does it pass, and does it pass the Alan Jude sniff test? Alan took it for a sniff.
Yeah, a couple things. Interesting thing that made they came up around the same time is that LastPass is now offering their sync to mobile service for free instead of being paid.
Yeah.
Possibly because they're worried about people leaving and going to LessPass.
Okay, maybe.
So let's start with what it is and so on. So managing your internet passwords is not easy. You probably already use some kind of password manager to help you. You know, lots of them out there, but most people use one now. The system is simple, and the tool generates random passwords whenever you need them and saves them into a file or to some web service or whatever. And it's all protected with one strong password. your master password. This system is very robust. You only need to remember one password to rule them all, and now you have this unique password for each site on the internet. But there are some shortcomings to that type of password manager, and so they were trying to address that. So their first question is, how do I synchronize this file to all my devices? I would prefer something self-hosted rather than something like LessPass where they host it for me. But then it's, maybe for me, it wouldn't be that hard to set up my own server that I could access from my phone and so on. But for some people, it's like, not everybody has their own droplets running and wants to deal with all that. Just
and honestly,
to synchronize your passwords.
If we make there too many pre-requirements to having great passwords and individual passwords for each site, people just won't bother with it. They're not going to go through that hassle, and they'll just use bad passwords everywhere.
Right. Well, so while most people that watch TechSNAP maybe would be comfortable with setting up a droplet and using that for their passwords.
Yeah.
It's not something that my girlfriend's going to do.
No. Yeah. It's not something that most average computer users are going to want to use at all because it's too much hassle.
So that, things like KeyPass become a problem when you have to synchronize it to each device. So that kind of leaves you with something like LessPass where they store the passwords for you, but then, there's some privacy and security concerns there and so on. The next question is, how do I access a password I need when I'm on my parents' computer and I don't want to install the password manager? So with LessPass, you can log into the website and do it, but with KeyPass, there's not really a good solution for that.
Okay.
Right?
Yeah.
And then the question is, how do I access the password on my phone? Do I have to install the app? Maybe I don't want to install the app. I just need one password right now, and then that's it. Again, with LessPass, there's kind of a way, although it's quite clunky if you want to log into one's website to open a different tab. Go to the LessPass website, log in, get the password, and copy it over to the other thing, and so on. So LessPass tries to solve all of these. So the LessPass system uses a pure function, a function that gives the same, given the same input parameters, will always give the same result. In our case, you give it a login and a master password and the name of the site, and maybe some options, and it returns a unique password. So there's no need to save your password in an encrypted file. You just need access to the tool, which is just some JavaScript that you can put on a website or whatever, and you can just recalculate the password every time instead of having to remember it. So it's basically doing a key derivation function on your password to make a longer key, and then using SHA-256 with the site name, the username, a counter, which we'll get to in a minute, and the various options, and it generates a password. And basically, if you ask it to do the same thing again, it'll come up with the same password every time, and that way you have your password for that site.
Okay.
Right. So now, instead of having to have access to this database, you can just generate this individually.
So no syncing required.
Right. There's no syncing because there's nothing to actually write down.
Yeah.
Or is there? The other problem with that is you have to remember the login name yourself. Now, for most, that's not usually that hard because, most times everybody tries to use the same login name for everything if they can, and a lot of sites.
But some of us have multiple business logins and personal logins and family logins.
Right. Well, that's why it's good that it does use the login name, because then you can have two different passwords for the same site.
I just have to remember them, though.
Yeah, you have to. So we'll get to. So there are some issues, though. Some sites have different password complexity requirements. Like my bank won't let me use more than 14 characters in my password, or another bank requires that they have a PIN number instead of a password, and so it has to be all digits. So by default, LessPass didn't really work. So LessPass instead came up with this idea of password profiles, where you can control the restrictions on what the output should look like.
Okay.
The other thing is some sites obviously don't hash passwords correctly, and they might say, "Oh, you can't use a $sign in your password," and so you needed some way to solve that as well. And then the other problem is, so if it's just based on a hash and my password will never change, that way I can just keep regenerating it. What if I need to change my password? Right? What if the site has a password change policy every 90 days? Or what if I accidentally pasted the password into IRC or whatever and I need to change the password? That's where that counter variable comes in. So it's just like, oh, this is my second or my third password, and then it allows you to generate a different password for the same site. of course, the problem is, again, with no storage, you would have to remember that this is your fourth password for Gmail or whatever.
I feel like I've heard this concept before, either in individual...
This concept would come up a number of times before, people trying to do this. Now, most of those times it was just using like a straight SHA-256 hash or something without the key derivation function. So this is slightly better than that. But yeah, obviously you're into this problem of now, instead of just working like it kind of describes in the original outline, you have to remember... You go to the site and you have to remember your login, your master password, what password profile it's being used, how many times you've changed your password on that site, et cetera, in order to log in. So, you're back to remembering all this other stuff instead of a password.
Mm-hmm. I guess, yeah, and even if you wrote that stuff down, it would leave you sort of vulnerable. So,
exactly.
Yeah.
So to manage to change the password, we have the counter, like I mentioned. So, of course, now you have to remember your login, master password complexity rules, and how many times you change your password. So they came up with a connected version of their plugin, which actually connects to their website, and it remembers your login name, the password profile, like, oh, this password can't have $signs in it, or this password's only numbers, or this password can't have a length more than 14 or whatever.
Okay.
And how many times you change your password on that site, so that you don't have to remember all that. And so then it becomes much more like a LessPass type thing, except the actual password for the site is never stored on their database.
Mm-hmm.
But that has some privacy concerns and security concerns, right? If how easy is it for someone to get that list? Can I just connect and see what websites you happen to have an account on?
Yeah.
It's like, oh, look, Chris has a Pornhub account.
And does LessPass save the metadata of every time I connect and what website I'm asking to have the password for?
Yes.
Username for?
Where I connected from, which site I was logging into, or anything like that.
Is that all it is?
On their website, they go on to like, oh, we don't use Google Analytics on our website and stuff for your privacy. But yeah. Even if they're not doing it, it would be a target for the government to go after their servers to monitor that metadata.
I mean, really, if you could just prove I'd logged into a website 3 times a month, is that really... I mean, if you could...
Or that you
attempted
logged into that website at this time on this day.
Yeah. That seems like what law enforcement would need.
Yeah. And then the other question is, how do they actually protect the connected version's information, the metadata, like the actual... just knowing how many times you change the password on the site or whatever. You log into their website with a username and password. Is that your master password? Maybe it's not supposed to be, but how many people will do that? And then if I compromise even the hash database and manage to brute force some of them, I now have that person's master password, a list of all the sites, and the change counters and everything. So I know every one of their passwords for every one of the sites, even if I didn't have... it would be the same as if I had compromised something like LessPass and I had to crack it that way.
Do they now? They offer like a self-hosted version of this too, right?
So they do offer a version where the connected part is hosted by you, which solves most of these concerns. Although, if there's a flaw in the software, it just they hack your server as easy as they did to hack somebody else. They're less likely. A bunch of small targets are less likely to be targeted than the one big one. But
I do like that they suggest that you install this Docker image and then give you a bash command that calls curl, which pulls down a shell script.
Yeah. So they so instead of a curl pipe bash, they do bash in from subshell curl, so that when you stick sudo in front of it, you're sudoing the right part. Yeah, you don't want to run curl as sudo. You want to run bash as sudo. So your regular curl pipe bash doesn't. If you stick, everybody's reflex is to put sudo at the front of the command.
Sure, and just run the whole thing as sudo.
Instead of bash. So
it
just feels weird to run curl pipe sudo bash.
I think it's just funny though that it's like
the nature of it, so that people will just copy and paste this command.
It seems pretty interesting, although it seems like it's kind of like, well, all right, use this magic Docker container to set it up, and then use this magic shell script
that will download and install the Docker for you. But yeah, I couldn't find easily.
It's nice. It'd be nice for testing. You know what?
Yes.
I definitely appreciate it for testing. I would just also would love to know how to build it myself.
Yeah. Well, I don't know if on their GitHub somewhere is the recipe to actually build the Docker container. Maybe I don't know. Because on an OS like mine that doesn't use Docker, it's like you can run these Node apps and so on FreeBSD in a jail just as easy. So I'd rather have a recipe for that or something.
Mm-hmm. Mm-hmm. Okay, so interesting so far, though.
So the question is, how do they actually control and restrict access to the connected data? Even if you self-host it, if the protocol is not secure, there's a problem there.
But I like being able to put it on my own box if I want.
That does help a lot. So you can host your own LessPass database if you don't want to use the official one. The requirement for self-hosting is that you have Docker and Docker Compose installed on your machine. And the fact that the installation instructions are curl pipe bash, although written in a slightly different way, does raise some concerns for me, but whatever. So this leaves a few problems left.
Okay.
The first one is that you can never change your master password. Because if you do, all your other passwords change.
Okay.
And you can't get the old ones back.
Now, didn't we just recently cover a Google study that said just use a really great long password and that's more secure than changing it with like an 8-character password all the time? Like I thought there was just a study that argued.
We've seen a number of studies saying that, forcing people to change their password frequently will cause them to just come up with a lame system.
But you'd really want to make sure you picked a damn good one and that it was the only place you used it.
At some point, you might need to change it.
Yeah.
And something like LastPass, where basically that password is used to decrypt an encrypted private key that's actually used to encrypt your passwords, means that you can change the master password without having to, re-encrypt all of your actual passwords. And, the same thing is done on full disk encryption for the same reason, right? If you want to change the password on your full disk encryption, you don't want to have to go and re-encrypt every byte on your hard drive.
No.
And so they don't really have a system for that, mostly because it would require storing an encrypted master key somewhere that you would decrypt with that master password. And there's no way to do that in this system.
And they're trying to avoid that.
Yeah. So changing your master password is problematic. It would basically require you to change your password on every single site that's in your password database, which if anything like mine, it's hundreds, and that would just take all day. Other problem is it is still technically possible for someone to brute force your master password, especially if they know your encrypted password for a couple of sites. That can help them figure it out. But each attempt will require them to do the full run of the password-based key derivation function. But the default in this LessPass is to use 8,192 rounds of that. But that's actually not very many. The default for the standard when it came out in 2000 was 1,000. But nowadays, you probably want a lot more than that based on how fast CPUs are. And because you can run this function in parallel quite well, with some GPUs or some fancy, what are the things called you use for Bitcoin now?
Like the ASICs and stuff?
ASICs, that's it. Then you could actually, easily make something that does this really, really fast. And with only 8,000 rounds, that won't take very long to crack. If you remember the story we covered about cracking the full disk encryption on OpenBSD, they also used only 8192 rounds. And that was a number they picked like 10 years ago. And they've since changed it because it's not enough. And so because it can be parallels quite well, someone could eventually brute force your master password. Now they have all of your passwords, just like in LastPass. But the worst problem is they have more than just all of your passwords. Right? If they compromise your master password by brute forcing it or a keylogger or somehow getting your password, they have access to all of your passwords that you currently have, but also access to your new passwords. They have the password you're going to end up using for a site you haven't signed up on yet. They have the password that they can have, say, the next 10 of your Gmail passwords.
Jeez.
Because it's got this counter variable, they just take your master password and run it through with Gmail, but with the counter equal to +1 from what it currently is. And that tells them what your next password for Gmail will be, even though you haven't used it yet. And so they just generate the next 10 Gmail passwords, keep them from later, and every time you change your Gmail password, they already have the new one. And you'll be very confused. So there's could be some problems with the, basically, if it ever is compromised, there's not really a good way out of it.
Yeah, you'd have to abandon it and just switch to something else completely.
Well, or you'd have to basically start over with a new master password and change the password for everything.
Mm-hmm.
The key derivation seems weak. Like I said, 8192 rounds is not very many. For the server-side key derivation in LessPass, they use 100,000 rounds. Just to give you an idea of the difference between 8,000 and 100,000 for their server-side key derivation. On FreeBSD's Geli disk encryption, it does a micro benchmark on your computer to figure out how many rounds it will take about 2 seconds to do each password attempt. Now, that's probably too many for your password manager, but that on any modern machine, even like an old Sandy Bridge i3, that number is like 1.5 million rounds to take 2 seconds. So, 8,000 rounds takes like 0.0001 seconds. And that's on one core. If as the cracker, I can be running this on, all the cores I can rent from Amazon or whatever, or all the GPUs that I can run it on. And so it really reduces that key space a lot. So they probably want to crank that number up. In general, the reason why that number can be tweaked is because it was designed to constantly be increased as CPUs got faster. But because of the way they designed the app, that number is static, right? It's built into the app. If you change it, it will change all your passwords. And that's not what you want.
No.
So changing that number in the future will break everything. So I think at a minimum, what they should do is make that number, the number of rounds for the key derivation function, part of the password profile, just like, how many times you change the password and the password complexity rules, so that over time they can bump up the default and, your old passwords will still work, but any new password you make will use the higher number of rounds. And that way they can keep amping it up over time. And this way, if you want to refresh a password for a site, when you change the password, it automatically goes to the stronger number of rounds. So I've submitted this as an issue with them on GitHub, and hopefully they will add that feature before too many people start using it, because it'll obviously it'll be somewhat possible to make this backwards compatible if you're using the connected version where it's actually storing this metadata. Then if it doesn't indicate a number of rounds, then you know to default back to the old bad one or something. But anyway, this way you can control the strength for each individual password or whatever, and constantly, tweak that up so it takes, ideally, I think what you want for something like this is what you can do in JavaScript in about 100 milliseconds or something, or maybe even 200 milliseconds, something that will take an actual amount of time, but it's basically as slow as you can bear without it actually impacting you, so that if I'm trying to guess the million most popular passwords or whatever, then all I have to do, so that it will take, the fact that it takes 200 milliseconds per guess instead of, 1 millisecond per guess means it takes 200 times longer for me to try to crack a password, and that makes a difference. Another problem that LessPass can't deal with is single sign-on. There are a number of sites that have where I end up having the same password because they use an integrated backend of some kind. Whether this is, log in with Facebook or something, although most of the login with Facebook and Google things now, you don't have to re-enter your password, or it redirects you to Facebook or Google to re-enter your password. Yeah. But for things based on like Active Directory or LDAP, like, I don't know, most of the web services at FreeBSD are all in different domains, but they all sign on with one LDAP password. Well, if this thing's going to generate a different password for each site, it has no way to know that, hey, this is actually single sign-on.
I see what you're saying.
I suppose they could, in the password metadata, be like, hey, even though the URL says bugs.freebsd.org, use ldap.freebsd.org as the host name, so you come up with that LDAP password or something. So something that could work around, but it currently doesn't. And until it does, it means that if you log into, if there's 2 or 3 different things that all use your Active Directory password, then it's not going to work. And it basically doesn't have the ability to allow you to, tell it what your current Active Directory password is and just use that. You would have to change your Active Directory password to one that it came up with, and then tell it for all these other sites, use that, generate the password as if it was this site. But there are definitely some interesting aspects, especially the ability to self-host it. But I don't think I'll be switching right away.
Yeah, the self-hosting is a big thing for me, but I'll tell you what has become even more important is I don't want to compromise my security online because of mobile, and mobile is such a pain in the ass with these really long, complicated passwords that having a competent password manager on my mobile device is really important to me, and I'm probably not alone in that need. So you got to have a really robust mobile app to go with all of this stuff. That's part of it for me.
Yep. And I think open source is a great way to do that. But
yeah. So maybe they'll look at your issue you started. It is open source. You can self-host. There's a lot of things to like here. And you might just want to...
There's a bunch of edge cases they haven't thought about or haven't addressed.
Yeah, and so you might want to just give it time.
Yeah. The biggest thing is that because of the nature of it, making these changes later could be very painful. So we really, if this is going to become a thing, we got to kind of flesh out the bigger issues sooner rather than later.
Yeah.
And basically have some ability to, in the metadata, control some of this stuff. Otherwise, you're going to end up in a situation where, the new version requires you to change all your passwords.
Yeah, that could very much happen. Yeah,
and then you're just going to have somebody who's going to, switch to LessPass and just copy, generate all the passwords for the existing sites, push them into LessPass, and then give up on it.
You really got to really think deeply about this stuff. It sounds like they're on a good start, but there's still more to think about. Speaking of trying to make a good decision, that way later on when you change, there's not a ton of pain. This would be a great spot to mention iXsystems. iXsystems.com/TechSNAP. Go make a decision that later on won't cause a lot of pain. I have been in a situation where we made a big play to switch from one server OEM to another server OEM. And when we moved over to that new server OEM, they were plagued with both SCSI controller issues. This was so bad. SCSI controller issues and rampant tape drive issues. And back then, that was our backup solution, was tape drives in every server that mattered. And that was so awful that we then began a series of vendor hopping. And then when I got into contracting and I would go work for different clients and I would see what different hardware setups they had, I have to tell you, in my experience, none of those guys held a candle when I finally found iXsystems. iXsystems.com/TechSNAP. They build incredible systems for your home, your small business, or your enterprise, powered by Intel's processors that totally kick butt. iXsystems.com/TechSNAP. Go check them out. Support the show. I was over on their blog, and this seems like a really big thing. Now, I'm not in the federal government, so maybe I should not be speaking out of place here. But apparently, the General Services Administration has authorized the addition of iXsystems storage products and have given it the green light for use under the Federal Supply Schedule 70, which allows federal, state, and local governments to purchase products through a streamlined process with pre-negotiated pricing to save time. That's got to be huge for iX. That is great news, and they've got great products. You know about FreeNAS. Well, you can get a FreeNAS appliance, the FreeNAS Mini, and the FreeNAS Mini XL. You can just buy it right off of Amazon, or you can go to iXsystems and configure one. And of course, at the business level, they've got systems for storage and compute, incredible networking connectivity, and they work with people in the community at a level that gives them insight to the direction these technologies are going like no other company. Their hardware partners, their sales team, they all work hand in hand in an experience that's like nobody else. iXsystems.com/TechSNAP. And
whether it's a little TrueNAS Mini to go under your desk, a small 1U machine for your home data center, some machines for your home data, or literally racks full of machines for your data center, they do it all. The fact that you can still talk to a sales engineer and custom build your one little server. Most companies that normally sell racks full of servers or hundreds of servers at a time to people wouldn't give you the time of day if you only want to buy one. But iX still cares about, actually building that one server that you're going to use for things.
I'll tell you what, I think it just gives you a little insight into their culture. They're the folks behind MeetBSD going on this weekend as we record, or as this airs. And it's the November 11th and 12th. And they do this not because I can't imagine this makes iX a ton of money directly, but investing like this in the community, establishing these connections, finding new talents that they can maybe bring in-house and give them a spot to work and keep their projects going and later on leverage those to add value to the company. That's, I think, part of why they do MeetBSD. And if you want to learn more about that, you can check it out at meetbsd.com. Go to iXsystems.com/TechSNAP. And a big thank you to iX for sponsoring the TechSNAP program.
Yes, we'll be hanging out with them.
Yeah.
Literally when this airs.
Yeah. I'm imagining this is going to be a good tale. I love who wrote it, and I think I love what it's about. A very valuable vulnerability. This sounds fascinating.
Yeah, so it all started last week when I was browsing Facebook, or I actually got a notification from Facebook saying that Colin Percival had made a new post. And he says, I think I just accidentally exploited a receive arbitrarily large amounts of money security vulnerability.
Oh,
Oops.
Now Colin Percival, he's the guy behind TarSnap, and he's active in the FreeBSD community. So probably
used to be the FreeBSD security officer. He's like a mathematician and cryptography expert.
You guys talk about him on BSD. You guys have talked about him on BSD Now a lot too. So people who have watched that show are a little in. So this guy has some standing in this area, and for TarSnap, he's doing transactions, right?
Yeah. He also invented scrypt, which is a new password derivation system, kind of an alternative to something like PBKDF2 that we just talked about from LessPass. The difference is it uses memory instead of CPU time as the limiting factor, because while you can an ASIC will do certain CPU operations really, really fast and many of them at once, RAM is RAM and costs a fixed amount of money. So if you're the NSA, you can spend billions of dollars and get lots of ASICs to crack passwords, but you can only buy the same amount of RAM as everybody else does. Right? And so his system is basically designed to resist the NSA better.
That's fascinating.
So yeah, very credentialed person. But anyway, so he runs TarSnap, which is backups for the truly paranoid. It's an online backup service. And for that, he has to accept money from people. So he uses Stripe, which is a credit card processing service. He actually got me into their beta for Canada when they first launched it. And that's what we use at Scale Engine as well.
Super popular.
Yeah. Recently, well, not that recently, but at some one point, they added the ability to accept Bitcoins as payment as well.
Oh, that's nice for TarSnap. That's very nice.
Yeah. So let's start with Colin's blog post. He says, while I'm very firmly a white hat, it is useful to be able to consider things from the perspective of the bad guy in order to assess the likelihood of a vulnerability being exploited and its potential impact. For the subset of bad guys who exploit vulnerabilities for profit as opposed to selling them to spy agencies, for example, I imagine that there are some criteria that tend to make a vulnerability more valuable than others. One, the vulnerability can be exploited remotely over the internet. Right? If it requires you to be at the computer, it's worth a lot less money. The attack cannot be blocked by firewalls. That makes it even more valuable because it's going to be hard for people to stop you from doing it. The attack can be carried out without any account credentials on the system being attacked. I don't have to have a username and password on the system that I'm going to attack, so it doesn't require me doing a bunch of work ahead of time.
Ideal.
The attack yields money directly, as opposed to, say, credit card details that I have to then do another step to get the money out of.
Yeah, man, that's very nice.
Once it's successfully exploited, there's no way for the victim to reverse or mitigate the damage, right? There's no way for them to get the money back, right? If it's a bank transfer or something, they can usually manage to claw that back. But if they're giving you Bitcoin, there's no way to get the Bitcoins back. And the attack can be performed without writing a single line of code.
Oh, I'm loving this.
Anybody can do it. So he says, much to my surprise, a few weeks ago, I stumbled across a vulnerability that satisfied every one of those criteria. So he says, the vulnerability, which has since been fixed, or else I wouldn't be writing about it, was in Stripe's Bitcoin payment functionality. Some background for readers not familiar with this. Stripe provides payment processing services originally for credit cards, but now also supports ACH, which is the automatic clearinghouse for bank transfers, Apple Pay, Alipay, and Bitcoin. And it was designed to be a payment platform for developers that want to use it very much in the way Amazon did that for storage with S3 and compute with EC2 by presenting storage and compute functionality via simple APIs. Stripe fixed the get money from customers online problem with a very nice API. So Colin says he uses Stripe at his startup, TarSnap, and was, in fact, the first user of Stripe's support for Bitcoin payments because TarSnap has an unusually geeky and privacy-conscious user base.
Yeah.
And so that, the functionality for Bitcoin was very...
hence why it's such a damn good sponsor on the BSD Now show, because it's perfect for the Jupiter Broadcasting audience.
Yeah.
And so I know specifically I have gotten emails into JB like, can you please have Patreon accept Bitcoin? I want to support you on Patreon, but I want to use Bitcoin. So I know in the audience there's a desire to purchase some of these services using Bitcoin. I can imagine when you have something like a secure online backup that's super encrypted, that's the perfect candidate.
So he says, despite being eager to accept Bitcoins, I don't actually want to handle Bitcoins. TarSnap services are priced in US dollars, and that is ultimately what I want to receive. So Stripe abstracts this away from me. I tell Stripe that I want X dollars, and it tells me how many Bitcoins the customer should send and to what address. When the Bitcoins turn up, I get the US dollars I asked for and don't even have to think about Bitcoins. Naturally, since the exchange rate between dollars and Bitcoins fluctuates, Stripe can't guarantee the exchange rate forever. Instead, they guarantee the rate for 10 minutes. Presumably, they figured that the exchange rate volatility is low enough within 10 minutes that it's not going to cost them a bunch of money. So if the Bitcoin receiver isn't, if the Bitcoin receiver isn't filled within 10 minutes, so they generate this address and say, send 0.74 Bitcoins to this address. If the customer doesn't do that within 10 minutes, they cancel it and you have to get a different one, right? Because you're supposed to send it sooner than that. Otherwise, the exchange rate will have changed at that time and it'll have to be a slightly different amount of Bitcoins. So incoming coins are then converted at the exchange rate and he gets the money. For a variety of reasons, it's sometimes necessary to refund Bitcoin transactions. For example, a customer cancels their order or accidentally sends the wrong number of Bitcoins or even sends the correct number of Bitcoins, but not within that 10-minute window, resulting in their value being less than necessary, meaning that, you were supposed to pay me $20 and you sent me enough Bitcoins, but you sent them late enough that it's actually only worth $18 now. So I'll give you that back and you can pay me the right amount this time. So consequently, Stripe allows for Bitcoin transactions to be refunded, with the caveat that, for obvious reason, Stripe refunds the same value of Bitcoins, not the same number of Bitcoins.
Sure. Yeah.
So when they refund you because you sent it too late, they give you back, if they received $18 in Bitcoins, which was, 0.74 Bitcoins, but is worth less now, they're not going to give you back 0.74 Bitcoins because maybe the price has gone back up by then. They're going to give you back whatever $18 worth of Bitcoins is now. To prevent you from stealing money from them or for, making them lose out on the exchange rate. Colin says, this is analogous to currency exchange rates with credit cards. If you use a Canadian card to buy something in US dollars and then a month later get it refunded, the equal US dollar amount will typically translate to not the exact number of Canadians that you paid originally. It'll be some other number. So the vulnerability in this case lies in the exchange rate handling. As I mentioned above, Stripe guarantees an exchange rate for 10 minutes. If the requisite number of Bitcoins arrive within that window, that exchange rate is locked in. So far, so good. But what Stripe didn't intend was for that exchange rate to be locked in permanently and applied to any future Bitcoins sent to the same address. This made the attack quite simple. You pay for something using Bitcoins, you wait until the price of Bitcoins drops, then you send more Bitcoins to the address used for that initial payment, and then you ask for a refund of those excess Bitcoins. And now you get the Bitcoins refunded, but at the original exchange rate from before, not the current one. And now Bitcoins are worth less, so you get back more Bitcoin.
So like this morning, Bitcoin, when I woke up, was at $744, and right now it's $698.26. So if I had requested the refund right now, I would have gotten back the amount of Bitcoin at $744.
Yeah.
Yeah. That's a nice little trick.
It says, because the exchange rate used in step 3 was the one fixed by step 1 when you originally paid, which could have been months before, this allowed for Bitcoins to be multiplied by the difference in exchange rates. If step 1 took place July 2nd and steps 3 and 4 took place August 2nd, the arbitrary number of Bitcoins could be increased by 30%. Just keep doing this a bunch of times and you just turn one Bitcoin into 1.3 Bitcoins, and then again and again and again, until you have infinite money. Moreover, the attacker does not need an account with Stripe. They merely need to find a merchant that uses Stripe for Bitcoin payments and is willing to click the refund payment button, or even better yet, has set up some automated way to cause you to refund Bitcoin overpayments. So he says, needless to say, I reported this to Stripe immediately. Fortunately, their website provides the GPG key and advertises their vulnerability disclosure reward or bug bounty program. These two things I recommend that every company does, because they advertise that you take security seriously, and it helps to ensure that when people stumble across vulnerabilities, they'll actually let you know. He says, as it happens, he had Stripe's security team's public GPG key already, and he had liked them enough that he wouldn't have taken the time to report this, even if there wasn't a bounty. But it's important to maximize the odds of receiving vulnerability reports, so bug bounties are good. Since it was late on a Friday afternoon and I was concerned about how easily this could be exploited, he also jumped onto the Stripe's IRC channel to ask one of the Stripe employees there to relay a message to the security team of, hey, better check your email before you go home for the weekend.
Oh, man. Yeah, because there's very likely somebody else out there that's figuring it out, too.
Yep. Stripe's handling of this issue was exemplary. They responded promptly to confirm that they had received my report and reproduced the issue locally, and a few days later followed up to let me know that they tracked down the code responsible for the misbehavior and that it had been fixed.
Nice.
They also awarded me a bug bounty, which one that was significantly in excess of the $500 one they actually advertised. He says, as I remarked 6 years ago, Isaac Asimov's remarked that in science, eureka is less exciting than that's funny. Applies equally to security vulnerabilities. I didn't notice this issue because I was looking for ways to exploit Bitcoin exchange rates. I noticed it because the TarSnap customer accidentally sent Bitcoins to an old address, and the number of coins he got back when I clicked refund was significantly less than he had sent. In this case, Stripe corrected this anti-exploit of the vulnerability. So it just happened that when a customer did this, they actually got ripped off rather than making a profit. But it's important to keep your eyes open, and it's important to encourage your customers to keep their eyes open as well, which is the largest advantage of having a bug bounty program. And that's why TarSnap's bug bounty program offers rewards for all bugs, not just those that turn out to be vulnerabilities. You can get money just for finding typos. In fact, I've actually seen that happen. He was giving a presentation at BSDCan about TarSnap, and somebody found a typo on his slides, and he stopped his presentation and gives them $2.
That's great. That is great. It's good. And he all has it laid out right on his website, nice and easy.
Yep. And he also doubles the reward if you're looking at the beta version before the release, because he wants to get people to look at that code even more than the regular code. So he says, if you have code which handles fluctuating exchange rates, now might be a good time to double check that you're always using the correct exchange rate. But yeah, I thought that was a very interesting attack, and the fact that it was only found because somebody accidentally did something they weren't supposed to, which is send to last month's Bitcoin address instead of the next one, or just assume that they could just send money to the same address as last time rather than it being a different one each time, is the only reason this was found.
And it's neat that it's somebody we know, and it was a great write-up. And nice job on Stripe, too, which gives you sort of that peace of mind in the back of your back here, like, well, they've probably done this before. They probably are pretty good about these kinds of things.
Yeah. So, the fact that they have a security team, they have the bug bounty system, they have their key published, so it's easy to send them encrypted emails so that, other people, the NSA spying can also see what the vulnerability is. In this case, the NSA is probably not interested in stealing all of Stripe's money via Bitcoin bug, but if you were, say, the person that found that OpenSSH bug we talked about earlier, you'd want to be very careful when reporting that so that nobody except for the authors of OpenSSH find out about it until it's fixed, right?
Well said. Well, anything else, Mr. Jude?
Nope, that's about it for that one.
So let's take a moment and let's talk about Ting. This is a great mobile service that I think would work really well for our audience. If you're in the US, you should seriously consider going to techsnap.ting.com. You only pay for what you use wireless. This is very, very nice for me because I spend all day here at the studio and I'm on Wi-Fi. So everything that has anything that comes into my phone, any of the podcasts, music I listen to, I sync all that over Wi-Fi. I have 3 smartphones on my Ting plan. I don't use all of them. 2 of them go to other JB members, but 3 smartphones. And our average Ting bill is under $40 a month. If you really have just a little bit of tech savvy in you, you can probably make this work. But I think what's really nice about Ting is every now and then, when I travel, say I'm going to meet BSD, I know that I don't have to worry about, I might use too many minutes, or I might send too many text messages. I just will pay for what I use. And if one time I use a little bit extra, that's absolutely fine, and it all averages out perfectly fine. And what's also just super nice about Ting when I'm traveling, and every time I travel, this works out for me. They have GSM and CDMA networks, which means I've got a MiFi on Ting, and I have one for CDMA and I have one for GSM. I have 2 separate MiFis. But if you've got a Nexus device, you can actually switch. I moved my Nexus 5X from CDMA over to GSM to get better performance. And they have great tools, a dashboard that allows you to do all of this with an app that goes on the phone or your lap or your tablet. And they also have great customer service too, which you could just call and talk to them. And if you're a cord cutter, or if you just like to do some streaming media like the Roku, they have a great write-up on their blog. They just posted this. And they have great solutions even for people who have older televisions without HDMI ports. And then all the way up to 4K. They hooked everybody up. It's pretty nice. So 4K HDR and up, they have a good roundup of the different Roku streaming players on their blog right now. And I should mention they've launched the Moto G4 Play, which is a $150 very capable compact Android phone with a very simple, clean Android experience. $150, no contract, no early termination fee. It's unlocked. $150, you've got a perfectly usable Android phone, no contract. That's super nice. You can get a SIM card. We just bought another one this week. Or you can go get a full phone. TechSNAP.ting.com, and a big thank you to Ting for sponsoring the TechSNAP program. TechSNAP.ting.com. That's where you go to support the show and get the discount. And you can also call them at 1-844-230-5117. And tell them TechSNAP over here at Jupiter Broadcasting sent you. So, Alan, I wanted to mention, just because I feel like I'm in the travel mood right now, if people out there are going about, maybe they're going to go to a conference, they're going to go to family events. This is perfect for family events. I encourage them to pick up a sticker, a TechSNAP sticker at jupiterbroadcasting.com/stickers. We have a vinyl die-cut sticker for the TechSNAP program and for BSD now. Those are 2 of my favorite stickers on here. We also have the new User Air sticker. What you got?
They're actually cut to the shape. It's really cool.
Yeah. I'm also a sucker for circular stickers. So the User Airs are our newest circular one, which I like a lot. You can go grab some over at jupiterbroadcasting.com/stickers. We should do some packs. You should do some packs because who doesn't want to stuff stockings? Or you go over to a family member's house, you're at some sort of family dinner, just put it on the table. Just peel it off and put it on the table. You're gonna need a lot because you probably got a lot of tables. So jupiterbroadcasting.com/stickers if you'd like to grab one. Okay, with the news all done, let's do the TechSNAP feedback. Thanks for sending your emails to TechSNAP at jupiterbroadcasting.com. Or click on that contact link at the top of the Jupiter Broadcasting website and choosing TechSNAP from the dropdown. Our first email comes in from Zach, and he has a question about IPv6 versus Maria. I think it's Maria. He says, if I understand, part of the problem with large botnets made from Internet of Things devices is the fact that it all sits behind a NAT. Can we only tell where the v4 traffic is coming from, but not which device from behind the router?
Right. So, yes, that's true. Basically, we see the attack coming from a certain IP address, and we trace that back with the help of the ISP to a specific customer, but we couldn't tell what device at their house, or, especially if you look at something like, when I shared a house with 5 other people while I was in college, we each rented our room individually from the landlord and shared one internet connection. There'd be no way to prove that it was one person versus other that was doing it, or let alone, each person had 4 devices or something. So yeah, that's a problem there. He asked if IPv6 would be a solution. Yes and no. It would give you specific addresses, but it wouldn't necessarily be very easy to tie a specific address to a specific device on your network. It would make it easier than everything being behind NAT, but it wouldn't necessarily make it easy to have a one-to-one. Also, It depends on how the devices ends up working. A lot of these IoT devices don't support v6, but some of them do.
Yeah.
But the bigger problem is it really depends on which of multiple different ways the ISP rolls out v6 to the customer as well.
Yeah. Yeah, that's for sure. Yeah. They may roll out IPv6 in a way that is not what he's expecting. Maybe it'll still be IPv4 on the LAN. Alex writes
a lot of times they end up, in order for things to keep working the way people expect them to work, you end up actually having to use DHCP v6, even though with IPv6, the idea that you need DHCP was supposed to go away.
Yeah. But
it turns out people use DHCP to send out things more than just, say, your IP address. It's also your default route. So v6 has router discovery, but then it's like, oh, and here's your DNS servers, and here's your domain name, and here's your time zone, and here's where you want to pixie boot from.
Right.
And all of a sudden, you end up still using DHCP v6 or whatever.
Yeah.
And it's also the only way, it's one of the ways that the router could keep a list and know which devices are connected or whatever. But yeah, so his question is, since ISPs maybe know which IPv4 addresses attacks are coming from, they could just pull that address or block them. It's like, well, you could turn people's internet access off because they were compromised and attacking the internet. But, if you can't tell explicitly what device it was on their network that was doing it, they don't have much chance of fixing it, do they? Now, in this case, we know maybe some specific DVRs or something were the problem, and maybe, but the ISP doesn't really have a reason to do that. Most likely, if they just keep turning people's internet off, they're going to lose the customers. But in a couple of cases, if you're Comcast and you have no competitors, then maybe you won't lose the customer. But as if customers don't hate their cable company enough. Imagine if they kept turning your internet off.
Yeah, that would. Okay, so Alex writes, hey, Alan and Chris, I'm contemplating switching over to FreeNAS from our current setup of Synology NASs. Nothing's broken, but it's time to replace them, so either buy a new Synology or buy a FreeNAS Mini. A big concern I have is that I need a real-time replication between the FreeNASs. Synology does this with what they call Cloud Station. It's a two-way sync with 32 revision support. This allows me to have one Synology NAS at the main site and another offsite, and I'm able to access the share locally, and it sends any modifications over site-to-site VPN immediately upon saving and closing the spreadsheet. Please clue me in on how I would solve this problem with FreeNAS. Thanks, Alex.
Yeah. So ZFS replication is only one way. So you have a master and push to the slave. So you can have the backup at the offsite, and you could read the files there, but you would want them to be read-only on the offsite. And you'd want the changes to go to the main site and then be replicated back. This is an interesting question of how you would actually do that. There's some stuff like UnionFS, which you probably wouldn't want to get into, but it also doesn't really solve the problem, because when you mount the other one, it would only files that only existed at the offsite would be read from the offsite, and everything else would go back to the main site. So yeah, you could basically NFS mount stuff, but then, when you're reading a large file, like a video, you want to get the copy from the local machine. Just only if you make changes do you want to feed those back to the master machine.
What about something like a Libre Vault or a sync thing in a way where you set up where one side's read only and one side's the master, and you do that for both ends? So you're using. You would, in the case of sync thing, you would basically just have the two FreeNASs basically be separate and not be replicating to each other, and then use sync thing to manage keeping the files in sync across the two. Yeah.
That might be good. Your downside to that is if somebody tries to change the spreadsheet on both sides at the same time, how does it handle the conflict resolution?
Yeah, that's the problem. I don't know, and that's why I was wondering if you'd want to have separate, like you'd have to have read-only versions on each side. Maybe, I'm not sure. I don't know how you would.
This will be an interesting discussion at BPSD. We'll have to ask some people about this and see if anybody has any genius ideas.
Yeah, maybe so. Because Cloud Station's doing it somehow. They're using something behind the scenes to do it.
Yeah. I do wonder what and how well it actually works. But But yeah, you definitely have an offsite replica with FreeNAS, but generally, because the replication is one way, you want the offsite copy to be read-only. Now, if you could configure it somehow so that the share that you expose to users, it's like if for reading, if the file exists on the local copy, read it there. And then if you're making a change or you're trying to access a file that doesn't exist there yet, proxy it over the VPN to the master that has the latest version. That can help. But then you get the problem of, well, that file's been modified on the master, but it takes maybe there's like 10 or 15 minutes of replication delay, and you don't see the changes in the spreadsheet on the backup site until the replication is done. So it gets really complicated.
There's definitely file system ways to do this, but I mean, built into FreeNAS at a plugin level, that's going to be more challenging for sure.
But yes, this is an interesting concept, and hopefully we can maybe come up with a design at MeetBSD.
That'd be fun.
I'm kind of interested in this now that I've heard the question. But yeah, I don't know exactly how Synology is doing it, but and I don't know that I would actually trust it very much. But so yeah, when you just said you wanted replication with FreeNAS, I'm like, yeah, it does that, but the replication is only one way. Don't have a great answer for that off the top of my head.
If you have one, techsnap.reddit.com and look for 292 and let us know what you think.
You could probably cheese it and just have the two separate FreeNASs with no replication, and then use SyncThing to keep your stuff in sync. Depends, with a bunch of Office documents and it's not that many bytes, it's probably not that big of a deal. Although if you have millions of files or hundreds of gigs of files, then SyncThing maybe won't be that great.
All right, our back-to-back FreeNAS question comes in from Travis. He says, hey guys, I'm building my own NAS, and I had some tech questions about FreeNAS. Number one, when I'm planning to run ZFS, if I want to get things going, how many drives do I need to actually get going? RAID 6 versus RAID 10. I have a 10-drive bay total setup brewing. Okay. So that's number question.
Specifically, if you want to start with fewer drives and eventually grow into all 10, your best bet is probably the RAID 10, basically sets of mirrors, in which case, to start, all you need is 2 drives. And then you can add 2 more drives and 2 more until you fill all 10. And by the time you fill all 10, you probably want to replace the very first 2 drives with 2 bigger drives. And then you eventually do that with all 5 sets and just keep doing that over and over, and it keeps getting bigger and it works fine. With RAID 6, the smallest number of drives you need is 4, although 4 doesn't really make sense to use RAID 6 necessarily, because you would get more speed and the same storage out of running 2 mirror sets with the 4 drives, like a RAID 10 of a mirror set and a mirror set. Although technically RAID Z2 on the 4 drives means any 2 drives can die, whereas with the RAID 10, only 1 drive out of each of the pairs can die at a time. But in general, RAID 6 with less than 5 drives probably doesn't make much sense. But yeah, if you want the flexibility to basically keep growing over time, adding a smaller number of drives at a time, while the total storage capacity of RAID 10 is slightly less, the flexibility probably more than makes up for it. And that's why, when Chris keeps talking about getting a bigger one, it's like, I know you really want to get the most amount of storage for your money, but to have the flexibility, what you probably want is something with 10 or 12 or 16 bays and just add 2 drives at a time, so you can add the drives as you can afford them, as opposed to, and then eventually upgrade, if you start with 2 terabyte drives, because they're the cheapest per gigabyte or whatever, maybe 4 of those, and then once they're getting full, you add 2 or 4 more 5 terabyte drives or something, because that's what's cheap next year. And doing that, eventually you replace the 2s one at a time, but eventually a pair at a time eventually, such that you get the more space without taking up more drive slots too.
I think that's a system that seems like it makes a lot of sense. So
it gives you the most flexibility to add drives and upgrade without having to, if you have a 12 drive thing and you do RAID Z2s of 6 drives, then if you want more, you have to buy 6 more drives, and that can be a little harder to pay for at once.
So what do you think he's asking with that second question there. He says, if I use an M.2 PCI card, will multi-M.2 show up as different drives? And if so, could I make a dual drive M.2 setup to function as a boot drive and swap drive without much hassle? What's the? I don't know.
So if you're using the PCI card, it really depends, but I imagine most of them would expose the two PCI cards separately. Whether or not your BIOS will let you boot off of those drives is a question I don't know the answer to.
That seems like it'd be really fast.
Yeah, for a FreeNAS, you because booting, all it's doing is loading the operating system, and then that's it. The drive's read only after that. You can probably get away with your FreeNAS OS drive literally just being the USB stick, because if it dies, you can just flash FreeNAS on it again and plug a different stick in, and it just works. Right, all your data is still there, all your settings are still there because they're stored on the storage.
Yeah.
So you probably don't need to waste the whole M2 as a boot drive.
I hope he's not talking about for FreeNAS. That'd be a big waste.
Well, at some point there's a reliability concern, right?
That's nice. Yes, I suppose if it's not huge, if not expensive.
Well, you have to go get a new flash drive.
Yeah.
Because it's like, the power went out, power came back on, and the flash drive didn't work, and so FreeNAS didn't boot. That could be a problem. So maybe an internal one does, but yeah, you can. Last time I looked, I couldn't get a really, really small M2 to do that with. Like, I think the smallest one I could find was like 32 gigs or something. It's like, no, I want like an 8 gig M2. But yeah, you could probably use those.
All right, so Oscar writes in with a question about backing up a drive encrypted with LUKS. Hi there, I got a very short, hopefully easy to answer question. Is there a way to back up an entire file system if it's encrypted with LUKS? I'm thinking about maybe using DD or Clonezilla, etc. And by the way, I am on Endergros.
So there are two kind of answers to this. Yes, something like DD or Clonezilla will work. I'm not that familiar with LUKS. I'm not sure where it keeps the master key. I know in Geli, the full disk encryption on FreeBSD, it's in the very last sector of the file system, so it would be included if you DD'd it. I don't know for sure for LUKS, but you want to make sure you keep any metadata and other required files as well, like the keys for the encryption. Also, you could back up, if you mount the LUKS encrypted file system, then backing it up is the same as backing up anything else, and you could back it up with Bacular or whatever. Although remember that what you're backing up is the unencrypted files, not the encrypted files. The biggest thing is when you're using something like DD or Clonezilla, it requires that the file system not be changing while you're backing it up. So you basically would have to unmount your LUKS and export it and then DD the encrypted stuff, because if you're DDing a 2 terabyte LUKS encrypted drive and you change a file on it, then the backup was halfway through the drive, and you can end up with half the file before and half the file after, and all kinds of mess, and it won't restore properly.
That's good.
So the downside to something like DD is that you don't have.
It's a bat phone. It's a bat phone.
You don't have a way to deal with the file system being in use at the time.
Right. So Oscar, good luck with that. And now David writes with a question that I wonder if we'll have an answer for. He says, in short, how can I use a Chromecast across different subnets? He talks about how he's got like a setup where he's got a Chromecast in one subnet and a TV in another subnet. The TV has Chromecast capabilities built in, but the phone not on the same subnet. So it's not so easy to send from the phone to the television because they don't see each other.
Yeah, I don't know exactly what protocol Chromecast is using. Is it using some kind of like Avhide like link level stuff, or exactly what protocol?
Oh, it's something special and unique to them. So I don't know. I don't have any idea. I mean, here's the way I understood it worked.
DHCP relay or something. So I think it's MDNS. I don't know if there's such thing as an MDNS relay, so you could actually relay stuff between.
I think there is, but yeah. I was just going to say MDNS. So here's how I believe it works. MDNS is used for the phone and the Chromecast to see each other. Then the phone knows, I can send to this Chromecast, but then it uses the internet connection. Google actually sends the command to the Chromecast. Google is an intermediary in this process. So yeah. He says, I have a half a dozen smart TVs at work that we bought on the promise of being able to display flashy business intelligence reports, but in reality, to rotate the same thing they're using Chromecast wallpapers. But they have multiple subnets and VLANs for the sake of security and performance. Well...
So, yeah, apparently there's something called MDNS-repeater, which is a daemon that you can run on a router, and it will proxy the messages between your two subnets, as long as the router's in both.
So that's something to play with. It seems like, though, to David, this is probably, I got to imagine, something that hotels have looked into as well. So you might look down there to see what hotels do to solve this particular problem, and then let us know. I kind of this got to be something other people have wondered about.
I love the chat room all pasting the first result on Google that I found as well.
Yeah, chat room's good at that. They're super good at that. Now, we got a couple of emails that came in about, hey, what did you guys talk about last week? Could you mention that thing again? The BCP index, the best practice. Is that what this was? Best practices.
Well, so they were trying to remember what we were calling. They had like BSP or something, and it was like, yeah, so it's BCP 38, but. It kind of led me to ask, what are some of the other best common practices other than just, BCP 38 we were talking about of not allowing traffic to leave your network that's not from your network.
Yeah.
And so I found the index over at the Internet Engineering Task Force, and they have every BCP that's ever been published.
Oh, nice. And we have a link, so we'll have a link for that in the feedback section.
Yeah, so if you want to go figure out what, BCP 100 is, you can look it up.
Nice, Alan. Thanks. Yeah, and that'll answer a couple of questions that came in. All right, well, with the feedback all done, that means it's time for the TechSNAP Roundup. Welcome to the TechSNAP Roundup. Yep, that's what that crazy music means. The Roundup are stories that didn't fit up at the top of the show, but we still want to give you some links to follow up on your own after the show. And some of these links were supplied by our subreddit over at techsnap.reddit.com. I think perhaps this first one. Windows Atom tables have been popped by security researchers. So a security researcher has found a way to abuse the system-level Atom tables in Windows. All the versions, up to 10, Atom tables are defined by the system to store things with identifiers to access them. They can be global, like the tables that pass data via DDE between applications. DDE, doesn't ring a bell. Or
that's a Windows technology around since Windows 3.1 for passing data between applications.
I just can't remember. Dynamic something, data something probably, but I just can't remember. Don't remember anymore.
I think it's dynamic data exchange.
That would make a lot of sense.
Just made that up.
That probably is what it is, though.
Luckily, there's a link just below that says there's a detailed explanation of what Atom tables are.
Yeah. But I
have no idea what they are.
It is an interesting vulnerability, and keep it in mind as we go further down the roundup. But in the meantime, we take a little sidestep over here.
The million key question, investigating the origin of RSA public keys. So this is a paper that was presented at Unix, and basically by looking at your public key, like say the one for your SSL certificate, they can tell which program you used to generate it.
Oh.
Turns out that the way OpenSSL picks primes is different from the way RSA picks them, is different from the way PGP picks them, is different from the way that Microsoft picks them. They compared 4 different software and 4 different hardware key generators, and basically found that they're able to tell which one you use to generate a key just by looking at the key. The public key even.
I guess that's not too surprising. This wasn't too surprising either, but just something to note, Microsoft has stopped selling Windows 7 and Windows 8.1 to computer OEMs. No more.
Yeah, even before I guess they sold you downgrade licenses or whatever.
Yeah, and so no more Windows 7 Professional, Windows 7 Home Premium, Ultimate, none of that. It's all gone. All gone. So does that mean only Windows 10's being sold in stores now?
Basically.
Wow. Well, I guess it's time to move on, Alan.
Nope. When I give up Windows 7, I imagine my computer just won't have Windows anymore.
Yeah, that's what I was thinking. Yeah, I think a lot of people feel that way. Researchers
they need to hurry up and get Civ 6 working under not Windows.
Yeah, right. Researchers
I'm not going to buy a Mac either, so.
Oh, yeah. Well, and that now is not the time to buy into the Mac platform, I don't think. Okay. You can get a laptop that's incredibly expensive, or you can get a desktop that hasn't been updated in forever, unless you want an iMac.
Laptops is incredibly expensive and has a a USB device running a watch OS instead of a keyboard.
Yeah. Yep. With an ARM chip in it.
Yep.
Researchers make a high-performance battery from just junkyard scraps. Whoa, go tell Doc Brown. This sounds awesome.
Yeah, so this is actually a steel brass battery.
Wow.
Instead of
lead acid.
or lead acid or whatever. Apparently can very high performance and would be good for things like storing the electricity your solar panels generate in the day to keep you running at night and things like that.
Oh, interesting. Okay. Oh, now this one. I don't know. For some reason, felt like now this is just. We used to be China. If you watch this show, we've gone through waves of this. Apparently, Microsoft is trying to pin a recent attack and a hack on a Russian group. I don't really even. This is so hard to even believe that I have a hard time even reading it. But Microsoft's Windows chief.
Okay, so this one's. I decided not to cover the other half of this one. So originally, Google's zero-day project found that there was an exploit for Windows that was being used in the wild against people. And so while they found the vulnerability and reported it to Microsoft wasn't going to patch it until Patch Tuesday, which was 2 days ago, well, as of this recording. It was like November 1st, right? Was Patch Tuesday? Or is it second Tuesday? When's Patch Tuesday?
I think it's the second Tuesday, but then I thought they just moved it, so I don't know.
Yeah. Anyway, so normally Microsoft's like, all right, Google, but we're not going to fix this until Patch Tuesday. And Google's like, well, because it's being exploited now, we're actually going to release it publicly sooner, rather than normally, normally Google gives so many, I think it's like 30 or 60 or 90 days, whatever, as the max. But this one they decided because it was actually being used against people right now, that they would publicly disclose it and basically drop the 0-day. And I think they were hoping that would force Microsoft to drop the patch sooner.
So that's the interesting part of the story.
Well, the thing is that it turns out the only people this is being used against, it seems, currently, or before Google dropped the 0-day, was the Russian GRU using it against, the type of targets they go against, like diplomats and arms manufacturing companies and things like that, defense contractors. And that your regular home user probably wasn't going to get this used against them. But because Google dropped a 0-day for it, anybody could reverse engineer what the exploit is by looking at the details and eventually the fix. And so by Google dropping the 0-day on it, trying to force Microsoft to do the patch sooner, it could actually make more people vulnerable to it. And it, maybe we'll talk about this more next week, but it raises the whole question. It's like, well, Google doesn't want to wait because it's being used against people, but it's only being used against people who are actually state-level targets right now. And is it actually risking more people by actually trying to get the information out sooner?
Mm-hmm.
But at the same time, Google doesn't maybe want to decide who's worth protecting and who's not.
I find Microsoft's "well, don't blame us, blame the Russians" spin in this article on the BBC to be pathetic.
Yes, no, this one's, they're mostly saying blame Google for dropping this, but they only did it because it was the Russian. It's,
yeah, but if you look back at some of the examples they're using, one person was exploited via a phishing attack. Not even this vulnerability that Google disclosed, because the
phishing attack is the method the Russians were using to use the vulnerability.
I don't necessarily agree it was the Russians. I don't find the evidence compelling that it's the Russians.
Well, the BBC report is light on the details, but there are other reports that have more of the details.
Yeah, I've seen.
It definitely seems like this was a 0-day involving two things. There was a Flash vulnerability and a Windows Win32K vulnerability.
So it seems that the evidence is not
with an Excel document with Flash embedded in it.
Yeah,
that exploited these.
And according to this, there's like maybe something with the display driver that if you have also that could be an issue. So it says here that the Microsoft confirmed the issue with the system file, which Windows requires for display graphics, is part of the issue.
I think it's the Windows kernel API.
So here's why I don't find that compelling though to link any of this to I don't find any of their evidence actually any in this report or previous reports to link it to the Russians.
This is about the fix, but like the people who are being actively exploited with it were being specifically targeted by the Russian GRU.
I don't find that to be true though.
They were finding the specific department.
I know. I can't actually find anything that truly bears that out. I don't find any. There's nothing that really demonstrates
that. Doesn't carry that level of detail.
The only thing that you can really say is it seems to be targets the Russians would be interested in. Okay, I'll grant you that does seem to be the case.
Like, I can't remember which site had the link, but if we cover it more next week, we'll dig into it more and I'll show you what I'm talking about. But there's not uncompelling evidence that this was specifically state actors acting against defense contractors and so on. With spear phishing, meaning not regular phishing, but only a phishing email that was sent to like one person specifically.
Yeah. It wouldn't surprise me, and I don't doubt it's a state actor.
So it raises the question of when it's state actors going after specific people, is getting the fix out there immediately, does dropping the 0-day on it actually help us or hurt us? Right? Because, nobody except for the people being targeted was really going to have this used against them without Google dropping the 0-day. But once they did, then lots of bad guys get the ability to start doing this attack.
Yes, and it really widens the net. Okay. That's a question I feel like we've been.
Thing is, so the vulnerability there was two things. There was the Flash one and a Microsoft one, and Flash managed to get a patch out in like 4 days. And at that point, when Google decided that Microsoft wanting until like 3 weeks later, during their normal patch cycle, was too long, and that the word should get out sooner.
It makes me feel like there is another component to the story potentially. Like maybe, so didn't Google make some sort of inference like it's being exploited in the wild? Maybe they knew more about that than they wanted to publicly say.
They knew for a fact it was being exploited in the wild by a state actor.
So, all right. Maybe we'll know more next week. So this next link in the roundup, get ready for it. PDF warning. It's a big one. It's a PDF. Got to give people that.
So this is, again, from Unix, although this one's from the Symposium on Network Systems Design and Implementation.
This looks cool.
This is decimeter level localization with a single Wi-Fi access point.
Dang.
So what that means is using only one Wi-Fi access point, so therefore not using like triangulation or trilateration, figuring out exactly where you are to within 4 inches, or a decimeter is like 10 centimeters, so that's like 3.9 something inches. So figuring out like exactly where you are in your house within 4 inches using only one Wi-Fi access point.
Boy, this sounds like something Google would love to. Actually, I wouldn't be surprised if Google's not already behind or into some of this. Because you think about it.
It's interesting because you would have thought normally you would want multiple access points to try to triangulate.
Yeah, that's apparently. Yeah, that could be very.
Do this with only one Wi-Fi access point.
You know how this could be really useful too is just with assistive technologies. Like if you could track where people are at in a home, you might be able to for seniors or people that have special needs. You might be able to
on in rooms people are in and off in rooms people are not in.
That's obviously, for sure. But also just being able to activate microphones for voice commands in certain rooms and all kinds of stuff. You can see, and look at Google's potential, right? They integrate into the Google Home Assistant. You get that little Google Home Assistant in there. It's got Wi-Fi in there in the background. They're tracking everywhere you're going in your whole damn house. It's just a win-win. Well, for Google at least.
Anyway, if you want to know how that works, check out their paper.
Okay, I thought this was pretty cool. This is a little visual, so for the audio audience, just roll with us. But this is a stealth cell tower collection. Rogue cellular infrastructure disguised as... Here's an office printer as one, which is kind of my favorite. I think that's a particularly good one. And they do a little proof of concept here. They kind of break it open and show you where they took out where some of the motors were and and all of the guts for the printer and put in a cell tower. Here's another one, a cell tower disguised as a tree, which I thought was kind of neat. And one that's disguised as a palm tree and one that's disguised as a lamp pole. There's a whole bunch in here. One that's disguised as a ladder, or they actually just wrapped it with brick, so it kind of fits in.
Well, I think it's actually like brick paper, like wallpaper, basically. Just outdoor wallpaper.
Yeah, not actual rock. Yeah, kind of neat stuff. And they were going around experimenting with different stuff. And then it's just kind of a neat roast.
The printer one is interesting because they actually show it printing out a log of like the calls. You can see the text messages going back and forth.
Yeah, that one I like. That's the best one, and they started with it. So you can find the link to that in the roundup. Okay, so let's talk about this Kaspersky DDoS intelligence report. This has got to be interesting. This is for Q3, though.
Yeah. Well, that's where we just ended, right?
Is it?
So this is Kaspersky's report on denial of service attacks.
Does this have like this last stuff that just went down? Like, was it 2 weeks ago? That's what
maybe
I was
some
about.
of it.
Okay.
But anyway, if you scroll down just a couple of the graphs, they're pretty interesting.
All right. Okay.
So they looked at, most of the attacks were coming from China, but we're also going to China. The second graph shows where they were going.
I think you mean Russia. No.
Nope.
I'm just kidding.
Russia's not even in the top list.
I know. I'm just teasing.
Now, of course, this is where Kaspersky has data from. Although you imagine they would have more from Russia.
Yeah, right?
But you see that most of the attacks, while they're coming from China, they're also going to China.
Mm-hmm.
So, there's not necessarily a big thing there. But then if you keep going, some of the more interesting things, they looked at the average duration of the attacks. So there's the average size.
The average day of the week. Yeah.
That's much of a compromise, although sometimes it looks like there are more attacks on weekends.
Types of DDoS attacks, SYN attacks,
Yep.
TCP, HTTP, ICMP, UDP.
Yep.
Duration.
But then they look at how long.
Yeah.
So most denial of service attacks, about 60%, last less than 4 hours. Because, a lot of, especially with the booter services, whatever, your goal is just to, knock the Twitch streamer offline or whatever and not necessarily pin them down forever or whatever. It's just enough to be a dick, basically. And that not very many attacks actually last more than 2 days or so.
Yeah. That kind of makes you feel better, doesn't it?
Then they look at where the command and control servers are. Their data seems a little skewed towards South Korea there. I'm not sure what's up with that. But then the final ones were the interesting ones. Most of the components of the botnet, about 60 to 80%, were Linux devices.
What?
The amount of this botnet that's actually made up of Windows machines is going down.
Yeah, look at that.
Well, it turns out devices with Telnet enabled and a static root password are much easier to compromise than a Windows machine.
Yeah. A lot of Linux machines are straight on the internet, too. Come on, Windows. You can get those numbers up. You can do it. I have faith in you. This is interesting.
Of course, that's only percentage. If we looked at the raw number and so on, it'd be a little different. But
yeah, and it's only one source. It's Kaspersky. But I think I saw people kavatzing about this in the chat room. Level 3 drops its packets for hours, causing an internet traffic jam, says ours. And I guess when ours wrote this up, they were looking into the issue. Did you hear anything more about it?
Much more about it since.
Did you hear about CenturyLink's proposed buyout of Level 3 for $25 billion?
Level 3 has a pretty good reputation other than, the last couple of hiccups or whatever. They had one a couple months ago where human error brought down their network for a little while and so on. But they're basically one of the major backbones. And as far as when you're buying bandwidth, they're basically the premium one. CenturyLink is definitely not considered that great. Last time I looked at them, their pricing wasn't great. They just don't have the same reputation as being a backbone, really, even though they're getting pretty big because they keep buying up things. But, I think in general, it's the type of thing the government shouldn't let happen. We don't need more consolidation in this area. Having the plethora of backbone providers is a good thing.
Yeah, it's probably pretty important to a healthy internet.
One of our biggest problems is that the available number of ISPs is down to so few. The internet was at its strongest back in the day when, anybody that could nail a couple of modems to a pegboard could start an ISP. And, consolidation is only going to make it worse. So diversity is important for the internet.
Well, Microsoft wants to help. They're trying to take the crown from Facebook with look at us opening our hardware designs. And so they have announced on their blog that they have reimagined open source cloud hardware, and they've even included damn nice pictures down here.
So pretty interesting looking at how they want to put their hardware together. A couple of interesting things. The first one is they put the power supply at the front, which is slightly weird. Normally you have cold at the front and hot at the back.
Yeah.
But mostly the reason they did this is they have a custom motherboard. They wanted as much of the space at the back to be able to be connectors as possible. So by moving the power supply to the front, it gets it out of the way. What's interesting is they have room for 8 M2 NVMe SSD devices. They got their 50 gigabit networking and a couple other ports. They still support VGA because that's what most people's crash cards have. And it looks like on top of the built-in IPMI, they have at least one regular NIC and then the 50 gigabit NIC and so on. Also interesting, they have, even in this 1U chassis, they have room for 3 full height, half length cards. So 3 16X PCIe cards. Your dual CPUs, they're using some interesting heat pipes for CPU, and they go to a bigger optional remote heatsink. So if you're using a low power CPU, then you probably just have the heat pipes and that's it. But if you're using a higher one, they actually have this remote heatsink that will dissipate the heat even better. They got N+2 redundant fans, and the power directly uses 3-phase power. And so they're using dual 3-phase power supplies with built-in batteries. The interesting thing is you notice there's no port for the power. They're not using the regular modular power cables that everybody has. Those actually do take up quite a bit of room in a rack. So you can see there, if you scroll down to the next image, their PDU, which takes their 30 or 50 amp 204 volt or 30 amps of 400 volt power. And it looks like the chassis just connects to the rack and gets the power that way. It's a little unclear how you actually connect the power to the individual machines.
Interesting.
But if you got rid of the regular modular power cable that everybody's used to for CPUs, that would solve a lot of the, cable management problem in the rack. Right? Because normally you have like a power strip, and then you got all these cables running, and two running to each server, and you got to zip tie them all up and keep them nice, and you got all these cables, and you want some slack so you can slide a server out on its rails without actually disconnecting the power. Yep. And it makes cable management that much harder when you can't lock the cables in place. You have to have enough slack to be able to roll them out.
So in that one single little enclosure, it's a dual power supply, which I wonder how they deliver dual power. But anyways,
if you look at the PDU, there's 2 inputs.
Oh, okay. And then you said it quickly, but they've built in the battery to the power supply too. They probably have like a little lithium-ion battery in there.
Right. Google's been doing that since they built their servers on pegboards.
God, I would love to get rid of UPSs.
Well, this basically gets rid of the site-wide use. Normally in a data center, you have like site-wide UPSs, giant devices. There's probably more efficient to have the giant UPS, but there's more chance of it going wrong. And if it goes wrong, it takes out everything. Whereas if you have these in individual servers, then problem solved. Also makes it easier to, phase them out over time. All the old ones can just go away. What's interesting here is that, in particular, Microsoft tried to make this as universal as possible because they deploy sites all over the world. And so, the power voltages and so on are different in different places. So, rather than standardizing on like 208 volt or something, they support basically whatever that country they happen to be building this data center in has,
which is smart,
and then feed that into the computers.
It's pretty good design.
Yes, I'm interested in how they actually connect the power into the computer. I looked at some of the diagrams, but it doesn't really show. Like, they're not showing the front of the chassis here, although the front of these chassis looks like all it's got is some fans. Also interesting is that it looks like they might have some hard drives, but they're fixed. Like, they're just screwed into place. They're definitely not hot swappable. But it looks like they're mostly depending on NVMe anyway.
Mm-hmm. Yeah,
and then I'm guessing, they show at the bottom some bigger multi-use storage JBOD.
Yep.
So the storage is generally not in the individual machine. Maybe there's some ephemeral space, but that's it.
All right, Facebook, now it's your turn. You got to update your open data center stuff. See what you got.
Well, Facebook's older open data center stuff, the problem was they used a different size rack. So unless you're building a new data center from scratch, their stuff didn't make sense. It's like,
unless you got lots of money.
How about you make something that fits in these?
You got to be Facebook rich, and then it makes sense. So this
if you're building all your own data centers from scratch, it works. But
yeah, I think we just quickly, I just mentioned this because this is from Judicial Watch, and they have done a lot of good work, and they've been doing a series of emails. They've been publishing a series of emails that would seem to indicate that there is indication that maybe state actor, somebody who knows, was attempting to connect to Clinton's private email server now, and they themselves detected one of those attacks and instructed people to change usernames and passwords, etc. I don't know. I don't really know if there's much here, but I think it's interesting that Judicial Watch is reporting it.
Email server, you've probably seen lots of failed login attempts.
Yeah, sure.
A, they try to hack pop accounts and so on, because usually it's the same password for SMTP, and then they can start sending email. But also, it's a way to enumerate accounts. If you can just find out all the usernames that exist, it makes it easier to spam a domain, because you know which email addresses are valid and which aren't.
So I guess it looks like there was a series of 10 emails exchanged back and forth about a specific hacking attempt on the morning of Saturday, November 27th, 2010, which continued through Monday, November 29th.
But it's hard to say if this was an automated bot that was doing this to everybody's email server, or if it was specifically targeted on them.
Yeah. I thought that was interesting to note, because that could be a huge story if that turns out to be anything of actual interest, but who knows? Moving on, our last roundup link of the day, the teenager that accidentally launches a DDoS attack on the 9/11 system. Oh, no, that's not good.
The 911 system, right?
Yeah. No, I know. Well, yeah. 9/11. Not like 9/11. Never forget. No, 911, like the emergency system. Yeah.
Yeah.
Mm-hmm. Yeah. How does he do this though?
A Phoenix teenager mistakenly tweeted a link to a JavaScript exploit which forced iOS's devices to automatically dial and redial 911.
No.
The teenager created several weaponized versions of this bug, which would constantly dial a phone number or show annoying pop-ups. The teenager says he meant to prank his friends by tweeting the one that causes a pop-up, but he tweeted the one that made them dial 911 instead.
And then accidentally 1,849 people happened to just click that link. That guy's got some good traction. That's some serious uptake.
So in September, researchers calculated that it would only take 6,000 smartphones to take down any state's 911 system. While he said more than 1,900 people clicked on this link, according to the article. They raided his house and several items were seized, and they're charging with 3 felony counts of computer tampering. Which is interesting in this case is all he did was send a tweet, and it was actually a bug in iOS that made people's phones do this. So, it might actually be an overstep of the Computer Fraud and Abuse Act, although the Computer Fraud and Abuse Act, the abuse part is not about abusing computers, it's about prosecutors abusing the law. So.
Yeah, it is. Jeez. The funny part, is they would dial 911 and then automatically redial 911. That's awful. I mean... Yeah, just jammed up their phones.
Definitely a bug in iOS in this particular case, though.
Yeah. That was in September, I guess. So there you go.
Well, no, in September, researchers calculated.
That's when they calculated.
Research
so I was trying to track down when this actually happened.
Smartphones.
I was trying to figure this out, because did Apple publish a fix? That's what I'm trying to come down to. October 28th when this article ran, but it doesn't say when he did this. And I would like to know if they just quietly fixed this. Looks like it was on October 24th.
So apparently he has 12,000 followers, and about 1,850 of them clicked it.
This kid's got 12,000 followers.
He was arrested October 24th.
That's awesome.
Before that.
That was a hell of an accident. Wow, look at that guy. That's him right here. Well, there you go. Accidental DDoS.
But yeah, it's interesting that researchers already figured out it would only take 6,000 phones to completely take out an entire state's 911 system.
So just get
obviously these systems are not as robust as they should be.
So just get somebody really popular, get like a famous person's Twitter account, and then tweet that link out, and then it would be a mess.
Well, there've been a series of iOS updates in the last couple of days. Maybe it's fixed, maybe it's not. I don't know.
Well, there you go. It's still an interesting story nonetheless. Thanks for sharing it with us, Alan. That does bring us to the end of the Roundup. You can supply links to our Roundup by going to techsnap.reddit.com. Be sure to join us next week over at jblive.tv. You can get it converted to your local time at jupiterbroadcasting.com/calendar. We do it on Thursday afternoons, Jupiter Broadcasting time, but the calendar will tell you what it is, your time. Unless you live in the Seattle area, then you might have my same time. Alan, can I? Do you mind if I pass along your Twitter handle to people? Do you mind when I tell them? Okay, he's at Alan Jude. Don't
my name, so
just
it's not exactly secret.
Don't get that confused with anybody else. It's at Alan Jude. I know it's tough. I'm at Chris LAS, and you can tweet me as well. And you can follow the network at Jupiter Signal. And last but not least, I'll mention this show does have RSS feeds. That way you can get it every single week when we release a new episode. You can find them in the show notes over at jupiterbroadcasting.com. And links to everything we talked about also linked pretty much chronological order right there in the show notes. Okay, everybody, thanks so much for tuning in this week's episode of TechSNAP. And we'll see you right back here next week.